Hello students, today we are going to learn about a hysteresis curve for a ferromagnetic materials. We have a solenoid around a ferromagnetic material. When we flow an electric current through this solenoid, a magnetic field is reduced along its axis. This causes the materials to start magnetized. If we increase the current through the solenoid gradually, the magnetizing force also increases. That means there is the value of magnetic intensity goes on increasing. After that, if we plot the graph of magnetic field and magnetic intensity H, we obtain the curve OA. Why we obtain the curve OA? There is the saturation in the domains. So this behavior represents alignment of domain of ferromagnetic material until no further increase in I is possible. Therefore, there is no use of increase the current. Now we decrease the solenoid current and hence magnetic intensity H till it reduces to 0. The curve follows the path AB, which is showing that H is equal to 0 but B is not equal to 0. That means here we can say that there is some remanence in the magnetization. There is some remanence in the magnetization. That means some magnetism is left in the material. That is OB. So the value of magnetic field left in the material when magnetic intensity H is reduced to 0 is called retentivity or residual magnetism of that particular material. So after that we are going to reverse H. That means next the current in the solenoid is reversed and increased slowly. Certain domains are flipped until the net magnetic field inside it is reduced to the 0. Here if flipping of domains takes place, then we obtain the next part of the curve, and that next part of the curve that I can say is curve B.Sc. So we can say that we are obtaining the portion which is on the h-axis, that is OC. It means to reduce the residual magnetism or retentivity to 0, we have to apply magnetizing force or intensity which is equal to OC in opposite direction. This value of magnetizing force is known as a coercitivity of material. So we studied two concepts. One is retentivity, another one is coercitivity. After that, for the curve CD, as the reverse current in the solenoid is increased in the magnitude, we once again obtain the curve C to D. Then after that, next the solenoid current is reduced to curve DE. Then for further instant, there is solenoid current is reversed and increased. Then for further point we can obtain the next part of the curve, and that next part of the curve is the EF. Then if you obtain the curve EF, then we can say that it is clear that when a piece of magnetic material is taken through the cycle of magnetization, there we obtain the phenomena of hysteresis, and that phenomena of hysteresis is nothing but the lagging of intensity of magnetization behind the magnetizing field is nothing but the hysteresis. So here we can say that ferromagnetic material, then soft ferromagnets. When external magnetic field is removed, magnetization disappears in some of the materials like soft iron. These materials, we can say that the value of the coercitivity is very small. Then for hard ferromagnets, the materials like alloys of iron, aluminium, nickel, the magnetization persists even after the removal of external magnetic field. Such materials are the hard ferromagnets, and value of the coercitivity is large. So we can say that soft ferromagnet shows the narrow hysteresis curve and hard ferromagnet shows a broad hysteresis curve. That means for steel the curve is a broad.